we are in physics 3110018 is the code for the physics of group 2 branches. The student will gain knowledge of basic theoretical and mathematical concept of electronic materials is the expected course outcome of this from this module. There are 4 more. In this unit, you are supposed to gain idea about free electron theory. You should be knowing what is density of states and how it plays role in determining energy band diagram. Then Croney-Penny model, the latest free electron theory model. Then EK diagram, based on which we can differentiate between direct, indirect band gap material. Then types of electronic materials, basically conductor, insulator, semiconductor. Then density of states and occupation probability, Fermi level, effective mass, phonon. Now, so far we have done free electron theory, classical and quantum free electron theory we are done with. Density of states we have done. Croney-Penny model should be the topic today, but I'll need 2 lectures, and so I'll take extra lecture, most probably this Saturday, continuously for 2 hours. If we try to understand, it would be easier rather than having break in between. So based on that, we'll be able to understand the next 2 topics. Fermi level we already have done. Today we are doing effective mass and phonons. Started with classical free electron theory, and in that also we started with some very basic topics like current density, mobility, relaxation time, collision time, and then vector form of Ohm's law. Then we entered into postulate part of classical free electron theory. We had some derivations based on classical free electron theory postulates. Then we saw merits and lot many demerits of classical free electron theory. That's how we arrived at quantum free electron theory, which has its own postulates, its own merits and demerits. So to overcome demerits of quantum free electron theory, band theory was proposed, and base of band theory is Croney-Penny model, which we'll see next time. Then we had different types of statistics. We saw Fermi energy, Fermi temperature, Fermi velocity, and then we had density of states, Fermi Dirac distribution function. We discussed that at length. 7th topic is not directly mentioned in your syllabus, but it is very important to understand this unit, and 3rd one also. These are the possible questions from these topics which we have covered so far. Few definition, times and again I have repeated that you will need to know this formula so that you can solve numericals. Drift velocity E by m into tau. This, what is this m? Can anyone tell me what is this m?
Electronic mass.
Electronic mass, and that is half truth. Today we will come to know that there are some flaws in this theory. We assume that only E is the force acting. During derivation of this theory, this expression, we have taken F to be QE only. Today we will come to know that mass of electron is not constant. આ ડેરિવેશન જ્યારે કર્યું ત્યારે તો આપણે એવું મૂકી દીધું હતું કે ઇલેક્ટ્રોનનું માસ કોન્સ્ટન્ટ હોય એની ઉપરથી ડ્રિફ્ટ વેલોસિટી મળી જાય. Today we'll go one step further in our understanding. This is vector form of Ohm's law. Then we had 10 postulates of classical free electron theory. Then electrical conductivity, and then thermal conductivity. Now during this derivation also, see, all these derivations are based on classical free electron theory, and don't forget that classical free electron theory has its own limitations. Though it could give pretty good picture about the electrons and its behavior, and it could explain some parameters, but the theory was not foolproof. There was one very significant part missed out by classical free electron theory, which was phonon. And phonon, if you consider, the picture changes slightly, and that is one more topic we will be discussing today. This is what we got for thermal conductivity from CFET. Then we had Widman-Ferenc law. Merits of classical free electron theory, 5 merits and 10 demerits. And then we had QFET, quantum free electron theory, given by Sommerfeld, based again on some postulates. Merits of quantum free electron theory and demerits. Though the demerits, shortcomings are less, but not zero. And to go further, we need to understand different distribution functions. There are different distribution functions, different statistics, out of which we are actually compelled to choose Fermi-Dirac distribution function, which gives probability. This is Fermi energy at 0 Kelvin and at non-zero Kelvin, Fermi temperature, Fermi velocity. This is Fermi-Dirac statistic, Fermi-Dirac distribution function, Fermi factor, which gives us probability of finding electron in the energy level E when the temperature is T. This is how Fermi-Dirac function varies with the energy if temperature is 0 Kelvin. For other value of temperature, the variation in Fermi factor is slightly different with energy. Very important topic from exam point of view, density of states, without which we cannot find out number density of free electrons, without which we cannot find out so many other parameters about the material, electronic material. You will need this for today's topic. This last equation shows that G of E, density of state, is directly proportional to square root of energy, but this is applicable for 3D only. If you take 2D or 1D or 0D, the relation is different. So this is a graphical way of showing how to find out number density if you know Fermi factor and density of states. Then this was just for your knowledge mentioned during the lecture, that how G varies if the material is 2D or 1D or 0D. But the logic remains same if you want to arrive at N of E. Last time we had Schrodinger wave equation discussed. Once again, I would like to mention that this is not mentioned in your syllabus, but without this topic we cannot go further. And to avoid any confusion, it's better that you understand Schrodinger wave equation. So we had included this, in fact taken full lecture on this. So what is Schrodinger wave equation, how to derive the equation, and how do we find out solution? Though this fifth equation is the Schrodinger wave equation, if you refer in other books, the form may be slightly different. Let me show you the more popular form of this equation. Can I write this as h cut square by 2m d2 psi by dx square plus e psi minus u psi is equal to 0. I have just taken these two terms on the other side. So now if I multiply all the terms with 2m by h cut square, what I get is d2 psi by dx square plus 2m by h cut square e minus u into psi is equal to 0. This is more popular form of the Schrodinger wave equation, which is slightly different than fifth one look wise, otherwise both are same. After that we had derived solution of psi, value of psi for which this condition is satisfied, and value of psi which if you substitute in this equation, answer will be 0. So we had derived psi is equal to root 2 by L sine of kx, which is solution of Schrodinger wave equation. So this is what we have done so far. And now if you have any doubt, you can ask. If you have no doubt, we will go to today's topic. કોઈને કાંઈ પૂછવાનું છે? કોઈને કાંઈ અત્યાર સુધીના જે ટોપિક છે એમાં ડાઉટ જેવું લાગે છે? Anyone, any doubt?
No, sir.
Okay, thank you. Let us go to today's topic then. Task of the day is effective mass of electron and phonons. What is phonon we'll see, and we'll understand what do you mean by effective mass. So from the name itself, do you get any idea what a effective mass term should be meaning? નામ ઉપરથી તમને ખ્યાલ આવે કે આમાં શું હશે? ઇફેક્ટિવ માસ નો અર્થ શું થતો હશે?
Sir, electron constant accelerating position માં હોય, means we can consider it as constant velocity માં moving કરતો હોય તો સર એનો ડાયરેક્ટ માસ આપણે કેલ્ક્યુલેટ ન કરી શકીએ. ઇફેક્ટિવ માસ કન્સિડર કરવું પડે.
ડાયરેક્ટ માસ ને ઇફેક્ટિવ માસ એટલે શું?
તો સર એક સ્ટેટિક પોઝિશનમાં માસ હોય અને એક ડાયનેમિક પોઝિશનમાં માસ હોય, બે અલગ આવે છે.
વેરી ગુડ, બહુ સરસ ભૂષણ. આવું ક્યાંય પહેલા તમારે આવી ગયું છે?
હા સર, ઓલી ફોર્મ્યુલા હતી ને સ્પીડ ઓફ લાઇટ ની કમ્પેરિઝનમાં.
હા, ઓકે. સ્પીડ ઓફ લાઇટની થિયરીમાં આવું આવી ગયું હતું કે ફોટોનનો ઇફેક્ટિવ માસ, રેસ્ટ માસ એવું કંઈક અલગ અલગ હોય. That is true even for other particles also. Very good. Have you ever experienced your mass changing? તમારું માસ બદલાતું હોય એવું તમે અનુભવ્યું છે? એટલે આમ 2-5 વર્ષે બદલાઈ ગયું હોય એમ નહીં. અત્યારે તમારું કંઈક માસ હોય, તમારું દળ હોય 2 મિનિટ પછી બદલાઈ જાય, 1 મિનિટ પછી બદલાઈ જાય, એવું તમે અનુભવ્યું?
ફ્રી ફોલમાં થાય બાકી તો નથી.
વેરી ગુડ. તમે ઓલા ચકડોળમાં બેસો, ફ્રી ફોલ થાય, ઉપરથી ઠેકડો મારો, ત્યારે થોડીક વાર આપણને એવું લાગે કે આપણું વજન ઘટી ગયું, isn't it? Suppose if you are in some merry-go-round, બહુ મોટા ચકડોળમાં તમે બેઠા છો, and suppose if it is rotating like this. So when you are say in this position, you are here, લાગત ને તમારે જેવું જ લાગે ને. You are going up, and when you come here, say you are going down. એકને આપણે પોઝિશન A કહી દઈએ, બીજાને પોઝિશન B કહી દઈએ. Let this be position A and this one is position B. Now when you are on ground, suppose your mass is say 50 kg. So what will be your weight when you are at point A or point B? Same રહેશે કે નહીં રહે? વધશે, ઘટશે? Any comments?
ડિફરન્ટ રહેશે સર. A માં વધશે અને B માં ઘટશે.
બહુ સરસ. એવું શું કામ થાય?
સર
ગ્રેવિટીની
Okay. We say that weight is mg. Actually weight છે તો gravitational force જ છે, બરાબર ને? So weight is mg. Now in situation A, when you are going up, there is one more pseudo force which is acting down. આભાસી બળ હોય, આભાસી બળ નીચેની બાજુ લાગે, તો mg ની હારે બીજું કોક તમને નીચે ખેંચે. તો એટલા માટે તમારું જે ઇફેક્ટિવ માસ છે એ 50 kg નહીં રહે. So now if I carry out calculation, I will see that this m star will be more than 50. Okay, and if I talk about B situation, તો ત્યાં શું થાય? You are going down, so pseudo force will be upward. આભાસી બળ હોય ઉપરની બાજુ લાગે, તો mg minus ma થાય. So there if I calculate your effective mass, it will be less than. So this mass which varies depending on your situation is your effective mass. And આવું શું કામ થયું? Because there is one more force acting other than gravity. So in case of electron also, when the electron is moving, it is moving in solid આપણે એમ કહીએ કે ફ્રી ઇલેક્ટ્રોન છે, પણ એકચ્યુઅલી તો ફ્રી નથી, એની ઉપર ઘણા બધા બળ લાગે જ છે. See, in any conducting material, we have so many ions, right? And what these ions are doing? આ બધા જે ions છે એ શું કરે છે? શાંતિથી બેઠા છે? What they are doing?
Vibrating.
They are continuously vibrating, right? So when you connect battery, suppose you have connected battery, and then if you look at the electron, consider there is some electron which goes from one position to another position, and we say that force is equal to ma. Force is QE, that is ma. Then dB by dt or else Vd by tau. You find out Vd, that is QE by m into tau. Now this is not entirely true. Why it is not entirely true? Because we have made one mistake here. Force is not only QE. કારણ કે આ બધા જે ઓસિલેશન્સ થાય છે એ તે ઇલેક્ટ્રોન ઉપર બળ લગાડશે કે નહીં લગાડે?
યસ સર.
અને એટલા માટે તમારે ઈ બળ કન્સિડર કરવું પડે. So effectively what happens, so when you are talking about electron, it's not wrong if you write F is equal to ma, but which F? You have to consider two forces, F external and F internal, right? And then you can write this as like this. અને હવે આ દર વખતે બે ટર્મ્સ ન લખ્યું તો તમે એમ લખો કે ભાઈ હું તો ઇફેક્ટિવ માસ કન્સિડર કરીશ. This is not wrong, this is true, it's fine. What is m star? M star is the mass of electron considering internal force, and so m star is called effective mass. અને આનું સૂત્ર તારવવું એ આજનો આપણો એક ટોપિક છે. One of the topics today is to determine expression for effective mass of an electron, right? So write down this equation somewhere. હું વચ્ચે વચ્ચે અમુક ઇક્વેશન તમને સિમ્પ્લિફાય કરવાનું કહીશ, તો હું જેટલું કહું એટલું આ ઇક્વેશન નોટ ડાઉન કરતા જજો. આનો આખો આન્સર એ તમારે લખતા જવો પડશે. એ જ્યારે સ્ક્રીન ઉપર આવે ત્યારે હું તમને કહીશ. અત્યારે ખાલી આ એક ઇક્વેશન લખી લ્યો. Earlier, you must have somewhere studied that F is equal to du by dx. સ્પ્રિંગની પોટેન્શિયલ એનર્જી અને બળ વચ્ચેનો સંબંધ આવો કંઈક પહેલા આવી ગયો હશે. Must be in 11th standard. Force is negative gradient of energy. So based on that, I have written this. Now I can write this as velocity into time. Distance is velocity into time. I can always write, but whose velocity I am talking about? I am talking about the wave corresponding to electron, and velocity of that wave I am talking about. So it is Vg into dt. Okay, so I can write F as 1 by Vg dE by dt. Okay. Now we know that energy is h cut omega. So if I take dE by dk, let this be second equation. It is h cut d omega by dk, and hence d omega by dk is 1 by h cut dE by dk. Let this be third equation. You will soon realize why we are doing all this. So now I'll take Vg, which is d omega by dk. આવું ક્યાંથી આવ્યું? તો કે v is equal to lambda f multiply and divide by 2 pi. So you will have lambda by 2 pi and 2 pi f. This is omega and this is k. Okay, so you can write Vg as d omega by dk. What is Vg? Vg is the velocity of wave corresponding to electron. દરેક કણ માટે તમે એક તરંગ લઈ શકો, તો આપણે ઇલેક્ટ્રોન માટેનું જે તરંગ છે એનો જે વેગ છે એને Vg કહીએ. Okay, and it could be expressed as d omega by dk. Now using third equation, I can write this as 1 by h cut dE by sorry, should be dE by dk dE by dk. This is fourth equation. Now if I differentiate Vg, dVg by dt, if I take, I can write this as 1 by h cut d by dt dE by dk. Let me write on the slide. dVg by dt is 1 by h cut d by dt dE by dk, and that can be written as 1 by h cut d by dt dk by dt. Okay, it is nothing but simple maths. So that is 1 by h cut d2e by dk square into dk by dt. What did I do? I have just, instead of this, I have written d2e by dk square. Okay, no great thing. So then I can write this as h cut by h cut square d2e by dk square dk by dt. This is dvg by dt, that is actually acceleration. So acceleration is 1 by h cut square d2e by dt square into h cut dk by dt. Now I can write this as the last term I can write as f external. હવે આવું કેવી રીતે આવ્યું? How to get this? વિચાર કરો તો સમજાય છે આવું ક્યાંથી આવ્યું?
સર આ d2e by dk સ્ક્વેર આવશે ને એક્સેલરેશન ની ફોર્મ્યુલા.
Which one?
સર સાઈડ નું વાળું જે છે ને એક્સેલરેશન ની
dk
ફર્સ્ટ
square. Sir, you're right. It should be dk square. Is that okay?
યસ સર.
હવે આ જે લાસ્ટ છે એ ક્યાંથી આવ્યું એ મને વિચાર કરીને કયો હતો. Any explanation for this step? Just think and tell me. Any idea, any suggestion? Think. Recall all the formula for energy and force, and then just try to figure out how much relevant it is here. Okay, Let me explain. See, can we write F external as m star a? Is that okay? Force is equal to mass into acceleration, and acceleration can always be written as dvg by dt. Now there is one more way of writing force, that is dE f dx, and here if I take dx to be vg dt, velocity into time is distance, then what I get is force as 1 by vg dE by dt, right? This is what we get. Now we know that energy is h cut omega, and then dE by dk is h cut d omega by dk. So you can always relate this formula here. Again, if you take d by dt on both sides, you will get something. Let me differentiate. So d by dt, dE by dk, h cut d by dt, d omega by dk. If you differentiate and rearrange these terms, you will get this relation. Try out by yourself. I'll not go into that much detail right now. Otherwise, you may accept that h cut dk by dt is the force. And now look at the last step. My last step is giving me force on one side and acceleration on the other side. So can I have mass in between somewhere? આમાં ક્યાંક mass అయితే હોવું જ જોવે. તો આમાં માસ ક્યાં? એક જ ઇક્વેશનમાં ફોર્સ આવી જાય, એક્સેલરેશન આવી જાય, તો માસ అయితే હશે જ તે.
Sir, 1 upon the coefficient of f external.
Very good. So the middle term જે બ્રેકેટમાં જે છે 1 by h cut square d2e by dk square, that is second order differentiation of energy, multiplied by 1 by h cut square, is inverse of mass, and this indicates that mass depends on energy and actually velocity also. So if I compare this equation with A is equal to F by m, you compare this two and you will realize that m is 1 upon 1 by h cut square d2e by dk square, or else you can write this as 1 by h cut square d2e by dk square. This is the effective mass m star. So in case of electron, mass is not constant. Mass does depend on velocity. It depends on velocity of electron. Mass depends on the energy of electron, where the electron is, because in solid, when electron is moving, its energy changes depending on position. જ્યારે ધન આયનની નજીક હોય, ધન આયનથી આગળ હોય, ત્યારે એનું પોટેન્શિયલ અલગ-અલગ હોય, અને જો પોટેન્શિયલ અલગ-અલગ હોય તો એનર્જી અલગ-અલગ હોય, અને તો એનું દળ પણ જુદું-જુદું હોય. Okay, so that is what you are supposed to know about effective mass. Let us see this from answer point of view. If asked in exam, how do we write this? Let us see that. હવે જે આવે છે એ તમારે સાથે સાથે નોટબુકમાં લખતા જવાનું છે. As soon as this lecture gets over, you will submit this answer. What is effective mass? Derive its expression. That is the question, and here I am showing you the answer. When an electron, આખી સ્લાઇડ પહેલા તમે જોઈ લો, એ પછી હું તમને લખવાનો ટાઈમ આપીશ, પછી નેક્સ્ટ સ્લાઇડ ઉપર જશું. First understand this slide. When an electron in the periodic potential is accelerated by electric field or magnetic field, the mass of electron varies according to the velocity. Electron ને જ્યારે તમે બાહ્ય વિદ્યુત ક્ષેત્રથી બળ લગાડો, બાહ્ય વિદ્યુત ક્ષેત્ર કેવી રીતે એપ્લાય કરવું? તો બેટરી કનેક્ટ કરો. So when you connect battery, you are exerting external force on electron, and then its mass changes. How much is the change? It depends on how fast the electron is moving. Electron કેટલો ઝડપથી ગતિ કરે છે એની ઉપરથી નક્કી થાય કે એનો દળમાં કેટલો ફેરફાર થશે. The mass of electron is function of velocity and depends on energy. ઇલેક્ટ્રોનનું દળ એની ઝડપ અને ઉર્જા બે ઉપર આધારિત છે. Such velocity and energy dependent mass of electron is called effective mass and it is denoted by m star. Sometimes it is m0 star also. તો અલગ અલગ બુકમાં અલગ અલગ હશે symbol. If the force acting on electron is F, then according to Newton's second law, we can write F is equal to ma. Okay, and acceleration is F by m0. When the electron is passing through some solid, apart from this force due to external electric field, it also experiences one more force due to ions and other electrons, that is F internal. એટલે બાહ્ય બળ હોય એમ આંતરિક બળ પણ લાગે ઇલેક્ટ્રોન ઉપર. Now write down these 4 points, then we'll go further. Raise your hand when you are done. લખાઈ જાય એટલે તમારો hand raise કરજો અને થોડુંક ઝડપથી લખજો. I'm sorry, I cannot give you time more than this. You need to speed up. Take screenshot. જેટલું બાકી હોય એટલું લખી લેજો. We'll need to go further. So you need to consider external and internal force for F, and thus the resultant force on the electron is F external plus F internal, which can be equated with M0A. If you take F internal on the other side, then you can write the right side as M star A. You can drop this 0. You can simply write M star A. And that M star is effective mass. Okay. So now, according to quantum theory, we can always have a wave corresponding to the electron. So electron can be represented by a wave packet, and velocity of that wave packet can be given as d omega by dk. Okay. So once you have velocity, the advantage is you can reach acceleration. Once you have acceleration and force, you can find out effective mass. So Vg is d omega by dk, and that is 1 by h cut dE by dk, which I had earlier explained. Take 2-3 minutes and write down these 4 points. I need to do this exercise so that I can find out how many of you are attentive in the lecture. So randomly I'll be doing this exercise of asking you to write any answer from lecture. We know that E is h cut omega, and hence dE by dk, if you take, it is h cut d omega by dk, and hence d omega by dk is 1 by h cut dE by dk. This is how we can get this last step. Okay, let us go further. Most of you have written, others may take screenshot. So now we have acceleration is equal to dvg by dt. Substituting vg there, we get d by dt of 1 by h cut de by dk. Now instead of d by dt, instead of this d by dt, you can always write d by dt is d by dk into dk by dt. So that is what is done here. What is the advantage? Advantage is we know the variation of energy with k, and we know the variation of k with time. There is some relation of dk by dt with force, and so h cut dk by dt is external force. Okay, so when you are writing down, use enough brackets. This is one term, this is the other term. Okay, and this is the force. So now left side is acceleration, the right side is force into something. So you can say it is mass, 1 upon mass. And this is the expression for effective mass. The last equation is the expression for effective mass in the periodically varying energy region when it moves. It depends on energy, it depends on its velocity. So write down this much quickly. Then we will go to next topic, phonon. Those who are not done may take screenshot. જેટલું બાકી હોય એટલું પછી એડ કરી દેજો. Let us move to next topic. Next topic is phonon. And what is phonon? Phonon is very analogous to photon. Tell me what is photon? What do you know about photon? Photon શું છે?
Sir, photon is a particle which comprises of energy E equal to h.
Okay, it is electromagnetic wave plus particle. બરાબર ને, એનો ઇલેક્ટ્રોમેગ્નેટિક વેવ જેવો નેચર છે, તરંગ સ્વરૂપે છે અને કણ સ્વરૂપે છે, isn't it?
Yes, sir.
Similarly, phonon is also wave, in fact sound wave, and its particle form is called phonon. જો તમે પ્રકાશના સ્વરૂપનું કણ, પ્રકાશના તરંગોનું કણ સ્વરૂપ લ્યો તો એ ફોટોન કહેવાય. એવી રીતે ધ્વનિ તરંગોનું કણ સ્વરૂપ લ્યો તો એ ફોનોન કહેવાય. ફોનોન ઇઝ નથિંગ but particle for sound waves. So sound waves in Greek, phone means sound. So any upperthi phonon word I was. Phonon word was first time given by a Russian physicist Igor Tamm in 1932. He said that when the ions oscillate inside solid, when ions oscillate, they produce vibrational energy, and this vibrational energy is quantized. એના અમુક ચોક્કસ ઉર્જામાં તે વાઇબ્રેશનલ એનર્જી મળે અને એના જે પેકેટ હોય એને ફોનોન કહેવાય. ઇલેક્ટ્રોમેગ્નેટિક વેવના જે પેકેટ્સ છે એના જે ક્વોન્ટા છે એને ફોટોન કહેવાય. એવી રીતે વાઇબ્રેશનલ એનર્જીને તમે ક્વોન્ટા પેકેટ્સ લ્યો તો એને ફોનોન કહેવાય. So what is phonon? Phonon is like particle nature of vibrational energy, particle form or quanta of vibrational energy. Whose vibration we are talking about? કોના આંદોલનની વાત કરીએ છીએ આપણે? We are talking about vibrations of atoms or molecules of solid. And in some liquid also you can produce phonon, but you cannot produce phonon in gas. કારણ કે લિક્વિડમાં અને સોલિડમાં એક અણુ કે પરમાણુનું વાઇબ્રેશન થાય તો આજુબાજુ વાઇબ્રેશન ક્રિએટ થાય, એવું ગેસમાં નથી બનતું. There are two types of phonons, acoustic phonons and optical phonons. Phonon છે એના બે પ્રકાર છે, acoustic and optical. Now what is the difference between acoustic phonon and optical phonon? Let me explain. Energy of phonon can be given as h cut omega or hf, and momentum can be given as h cut k. What do you mean by acoustic phonon? See, whenever there is vibration, there are two possibilities. One possibility says that the positive and negative ions will vibrate together. They will vibrate in harmony with each other. They will go up and down together. So if you have this type of situation prevailing where negative positive ions are going up and down together, then it is called acoustic phonon. But if somewhere, if you see that this is how positive ions are oscillating and negative ions are oscillating in opposite manner. What do you mean by opposite manner? Opposite manner means this way. If this is the scenario, then such phonons, such quanta of vibration, such packet of vibration is called optical phonon. Okay, so for now, this much you should be knowing about phonon. Let us now see this topic from answer point of view, if asked in exam how to write. So a phonon is collective excitation in periodic arrangement of atom or molecules, means basically vibration of atoms or molecules. Phonons can be produced in solid and liquid, not all liquid, only certain liquid. Atoms vibrate about their mean position at finite temperature. These vibrations produce vibrational waves inside the crystal. Phonons are quanta. Quanta means packet of such vibrational waves, and they travel at speed of sound. Their wavelength is determined by crystal lattice constant, means જે કોઈ ઘન પદાર્થમાં છે એના અણુઓની રચના ઉપર ફોનોનની તરંગ લંબાઈ આધારિત છે. Phonons can only exist inside crystal. પદાર્થની બહાર હવામાં ન હોઈ શકે, પદાર્થની અંદર જ હોય. The transition that involves phonons without producing photons are called non-radiative transition. જેમાં ઇલેક્ટ્રોમેગ્નેટિક વેવ્સ ઉત્પન્ન ન થાય, ખાલી વાઇબ્રેશન્સ થાય, એવી સંક્રાંતિને નોન રેડિએટિવ ટ્રાન્ઝિશન કહેવાય. Presence of phonons affect physical property like electric and thermal conductivity of solids. There are two types of phonons, optical and acoustic phonon. This much you should be knowing about phonon. Take screenshot. આ આન્સર તમારે સબમિટ નથી કરવાનો, ખાલી ઇફેક્ટિવ માસ વાળો જ સબમિટ કરવાનો છે. So that is all for today's lecture. We intended to cover two topics, effective mass and phonons today, and we have covered. The possible questions from these topics are: what is effective mass? Derive expression for effective mass m star of an electron. What is phonon? Explain. So out of 22 and 23, 22 અત્યારે તમારે 2:30 વાગ્યા સુધીમાં સબમિટ કરવાનું છે. Okay, now if you have any doubt, you are free to ask.